In this lesson, we're going to take a look at what is called simplifying linear, quadratic, and polynomial expressions. Now, one of the most important things to understand about this lesson is that we're dealing with expressions, and expressions are different than equations. You'll notice in both the statements right here that we're going to look at shortly, there's no equal sign. This mathematical statement right here is not equal to anything. It is just a mathematical statement. We call that an expression. So there's no equal sign. We're not solving for x. All we're doing in this lesson is taking an expression and trying to compact it, to try to simplify it down to fewer terms. Now, simplifying linear, quadratic, and polynomial expressions involves two main concepts. The first main concept is combining like terms. So we'll see in this example right here, we've got 3x to the third plus 2x minus 8x to the third plus 7x minus 9. Now, what do we mean by combining like terms? In mathematics, if we have several terms separated by pluses and minuses, okay, that's what a term is. It is a statement separated by plus and minus from other statements. So in this case, I have 1, 2, 3, 4, 5 terms. I can combine the terms that are like each other. What we mean by like is that they have the same variable raised to the same exponent. So I'm looking at this 3x to the third and the negative 8x to the third. They both have the same variable raised to the same exponent. So those two terms I can combine together into a single term. And I do that by just combining the coefficients in front of the x to the thirds. 3 minus 8 is negative 5. So it would become negative 5x to the third. Now I also see that I can do that with these two terms. They both have an x, and in both situations they are raised to the first power. That's why there's no exponent there. So looking at the coefficients, that's a 2 and a 7. 2 plus 7 is 9. So that's going to be a plus 9x. And then I still have a minus 9 constant number here at the end. So this would be the simplified version of the original statement. By combining like terms, we simplified the expression. Now, the other important concept that's involved with simplifying expressions is this idea of distribution. It's a concept that you've used before and that a lot of you are familiar with, so let's just remind ourselves of it really quick. If I have a value outside of a set of parentheses being multiplied by that set of parentheses, that value belongs to every term in the parentheses. So again, terms are separated by pluses and minuses. So I have 1, 2, 3 terms in here that multiple of 3 out here belongs to. So multiplying that in, I simply multiply the like pieces. So 3 times 2 is 6, so this becomes 6x squared. 3 times 4x becomes 12x, and 3 times negative 8 becomes negative 24. So this is the simplified form after doing the distribution. Now, more often than not, we're going to end up seeing both of these concepts, combining like terms and distribution, involved in the same problem. So to take a look at both concepts being involved in the same problem, we've got this expression here that we want to simplify. We've got 5 times 3x to the third plus 2x minus 6 minus 2 times 7x minus 8. Now in this case, what I'm always going to start with is distribution. Okay. And in this example, I actually see 2 sets of distribution that need to take place. This 5 needs to be distributed into this first piece, and careful here, the -2 needs to be distributed into the second. That negative follows that too. So let's do this first distribution. 5 times 3x is 5 times 3x to the third is 15x to the third. 5 times 2x is 10x. And 5 times -6 is -30. And then this second distribution, again, remembering that that negative follows the 2, -2 times 7x is -14x. And -2 times -8, negative times a negative is a positive, so that's plus 16. So all of the distribution is taken care of. What I can now focus on is combining like terms. Now I only see one term that has an x to the third in it, so I'm going to leave the 15x to the third alone. But I do see that two terms have an x in it with the exponent of 1 on it. So 10x minus 14x is -4x. 10 minus 14 is -4. And lastly, I see two constants that I can combine. -30 plus 16 is -14. So this statement, this expression here, is the simplified form of this statement that we started with. And an important thing to notice is that I always write the simplified version from the largest exponent down to the smallest exponent. So if I had an x to the fourth in here, I would have actually put it first because it's greater than the x to the third term. So keep in mind that you want to order it from the greatest exponent term down to the smallest exponent term. We've got one more example here that we want to do, and it's an example involving fractions. So we want to make sure that we can do these not just with whole numbers, or integers I should say, but also fractions. So I've got 4x to the fifth plus 2x squared plus 4/3 times 2x squared plus 3x minus 5. So the first thing I see that I need to do is this distribution. This 4/3 needs to be distributed into each term. So I'm going to leave my 4x to the fifth plus 2x squared alone out here, leave them be, and now do this distribution. So 4/3 times 2x squared. Now we'll remember, if I have 4/3 times 2, think of the 2 as 2 over 1. How do I multiply fractions? Straight across the top, straight across the bottom. So 4 times 2 is 8, and 3 times 1 is 3. So it becomes 8/3 x squared. Next I have 4/3 times 3x. So 4/3 times 3, I'm going to do 3 over 1. Now what I notice here is I can cancel these, cross-cancel the 3's, and I'm simply left with 4 over 1. 4 over 1 is just 4. So distributing this 4/3 into 3x just becomes plus 4x. Lastly, I've got this 4/3 times -5. So 4/3 times -5, I'm going to do it as -5 over 1, is equal to, see, 4 times -5 is -20 all over 3 times 1 is 3. Now, -20 over 3, I don't think I can reduce that, so it's just going to stay as -20 all over 3. Great, so we did the distribution. That factor has been multiplied into each term. But now I notice that I potentially have some like terms that I can combine together. I only have one term that says 4x to the fifth, so we're going to leave it as 4x to the fifth. But I do notice that I have two terms here and here that have x squared. So I need to add them together. The question is, what is 2 plus 8/3? So 2 plus 8/3. Now I'm going to look at it as 2 over 1. But I'm not dealing with multiplication anymore. I'm dealing with addition. In order to add fractions, we have to have a common denominator. So here, my common denominator is going to be 3. I'm going to multiply top and bottom of the 2 over 1 by 3 so that it ends up having a denominator of 3. That gives me 6 over 3, which makes sense because 6 over 3 we know does equal 2. So we haven't changed the number at all. We just wrote it in a different form so it has the same denominator as 8/3. So now that I have common denominator, let's do the addition. 6 plus 8 is 14. So it's 14/3, which can't be simplified. But 14/3 is where we're at. So this 2x squared plus 8/3 x squared becomes plus 14/3 x squared. And then I only have one x term, so it's just plus 4x, and then minus 20/3 at the very end. So there we go. There is our expression simplified. We took care of any distribution, and we combined like terms, being careful to use fractions, to multiply fractions and add subtractions appropriately.